First, let's understand what the SKF oil injection method is, why you would want to use it, and what applications it can be used in. The SKF oil injection method allows bearings and other components with an interference fit to be easily removed in a safe, controllable and rapid manner by using a thin oil film to separate the surfaces. In applications with a tight interference fit, using the SKF oil injection method to remove your bearings offers many benefits. For applications that require pressures over 100 megapascal, such as couplings, marine propellers, gear and railway wheels, pressures of 300 megapascal, 43,500 psi, are more typical, and SKF oil injectors are preferred. In these higher pressure applications, the SKF oil injection method program can be used by your maintenance or design department staff to select a pump with the correct pressure required. For instructions and guidance on how to perform the SKF oil injection method, please refer to our easy-to-use instructional video. Now let's look at how to use the SKF oil injection method program itself. Within the Calculation of Components with Interference Fit section of the program, we have three options. 1. A cylindrical seat. 2. A tapered seat. 3. A tapered seat with a sleeve in it. Let's start by looking at a cylindrical seat example. We take an interference fit of 0.040 millimeters. We don't have an axial load. Let's consider that we have a shaft of 50 millimeters, and that E, the modulus of elasticity for steel, and the Poisson ratio are as shown here. For the outer sleeve, we will select 70 millimeters, and we have the same values for the E module and Poisson ratio for steel. Next, we set the width of the joint as 20 millimeters. And we have H, a smooth factor based on the surface finishing, which has a recommendation of 0.0025 to 0.005. If you're not sure about any of the selections, you can click on the question button and you will see an explanation of all the parameters. And for example, you can see here is where we get the values we input for H based on the surface finish. If you're not sure, then to be on the safe side, set H to be 0.0025. The operational coefficient of friction by oil injection should be selected as 0.14, and the mounting coefficient of friction should be set to 0.02. Based on the material of the other sleeve, we will set the yield stress to 1570. And when you click Calculate, you get the following information. First of all, we see the surface pressure on the outer sleeve is 31 megapascal, and with a service safety factor of 2, you should select a pump of 60 to 70 megapascal to overcome the interference fit. The measures for the external extension are provided here. The stress information about the shaft and the outer sleeve is shown here. And the force and the torque that is needed in Newton meters is shown here. Now let's see how this looks for a tapered seat. For the taper seat, for a bearing it is 1 to 12. We will base this on expansion and we will use the value 0.040. Here there is no change since it is still steel. Again, we click on Calculate and we get the same result. And with a safety factor of 2, the pump required should be able to deliver up to 100 megapascals in order to separate the surfaces. Finally, when it comes to the tapered seat with a sleeve, as you see, we get an area to provide information for the additional material. And of course, we need to provide data for the new outer sleeve dimension. We will set this to 65 in this example. Then we click on Calculate and we can see the pressure that is needed and the same information as before. When you are finished, you can click on Report and this will generate a PDF report file from this data. Thank you for viewing this instructional video on how to use the SKF Oil Injection Method program. We hope it was useful. Full information about the SKF range of pumps and equipment required for the SKF Oil Injection Method can be found on skf.com.